How is everybody? Still here. The obligatory AV issues at an informatics conference, that does not go away. Someday AI will fix it for us. Okay, so I've kept this fairly informal. There's only about 15 slides. I'll weave some stories along the way. The goal is to sort of make it interactive. Feel free to interrupt at any time. First, I want to share the perspective where I'm coming from. I have two jobs. Half of me is a faculty member writing grants, papers, students, the graduate program, the usual drill of an academic. And for the past 2 years, I've been in the health system as chief data scientist for Stanford Healthcare, which is by all accounts a tiny health system with 2.5 hospitals that add up to about 900 beds, give or take. And over the years, I've sort of gone from being a ISMB person to being more of a healthcare person, and we'll sort of chart that journey along the way with some references to some mentors who are here, who don't know what I'm going to say about incidences that led me here. Okay, so to dive in, this is perhaps the most important slide, and Soren's talk sort of got into this a little bit in terms of trajectories. I'm putting out a full timeline, let's say by the hour, just for argument's sake. So we have time going left to right, and below that, whatever really happened, we capture a reflection of that in some data stream that we collect. In the US, we love to bill, so we collect IDs first so that we can send a bill to somebody. And then we have all of these different data types: waveforms, numerical data, notes, medications, we take pictures. Every hole in the body, we send a camera up and we take a picture or a little video. We put people into giant magnets and spin them around, and we collect some signals and then turn them into pictures. We can collect genomic data. We can collect metabolomic data. A lot of those are points in time. Like, I don't know if anybody who collects the genome like 5 times for the same person. Maybe cancer genome, you might do that as you see how the tumor is responding. And this timeline view holds for other things as well. And I'm going to shove in my thesis work where I was studying yeast biology, and as time went on, yeast were given some shock or deprived of some nutrients, and then some data were collected. So this timeline view is really important. For patients, only a part of the timeline is captured in the electronic medical record. A lot of it is outside in the form of variables, patient-reported outcomes, their environmental exposures, the exposome, as Mike Snyder likes to call it. But we take this construct, let's give it a name. Let's call this a patient timeline object. And we probably have it for anywhere from 1 million to 200 million individuals, depending on where you are in the healthcare ecosystem. The largest I worked with is about 800 million patient timelines. And then we build models. And when I use the word model, I use it as a noun, because it's both a noun and a verb. And the noun form means it's a representation. It's an imperfect representation of reality. It could be in the form of differential equations, it could be in the form of rule-based systems, logistic regression, deep neural networks, doesn't matter. But it's a representation of how you believe the world is operating. So we use these timelines to build models, and then these models help us do 3 things. We classify, medical people call it diagnose, we predict, prognose, or we recommend some decision or some action. The colors are that the recommendation is you need causal integrity, so it's a bit harder. That's why it's a different color. And we can do these tasks in order to advance the science of medicine, the practice of medicine, or the delivery of medicine known as healthcare. So that gives us this 3x3 table. So I've sort of wandered around in this matrix. I've spent time in each of these 9 cells. I'm not going to tell you about all of them today, obviously. I started my journey here, building this thing that probably, aside from Larry Hunter and Russ, nobody else even recognizes. Inspired by work by Moore Peleg in Russ's group, I don't know when that was, 98, 99, when the biontology SIG started. And the reason I'm mentioning all of this is not just for pure nostalgia. It's because communities matter. For the students here, how many students today here? A decent chunk. Look around you. Of those that had their hands raised, you're going to keep seeing them for another 20 years. And for the ones that didn't raise their hands, they're going to be writing letters for you for the next 20 years. And these are your tribe. So get to know them, network with them, go to lunch, go climb Mauna Kea, go take a dip in the ocean. The anecdote I wanted to mention is in 2003, ISMB was in Brisbane. And that was my first conference ever. I knew nobody. And I had a poster, which barely 10 people came by. But I saw Larry giving advice to another student. You might not even remember this incident. And for like good 30 minutes, he's counseling this complete stranger of a student in terms of how to think about science, how to think about grants, how to plan a career. The person was quite dejected down at that point. He cheered him up. And then next year I found Larry again, and I was like, and we had gotten to know each other, and then I asked him, like, why did you do that? And his answer was that in this community, there has to be efforts where we give with nothing expected in return. And for those that are in the Beamer division, you've heard me say this often, that is what makes a community tick. Give more than you take with nothing to expect in return. And that incident is something that made me sort of welcome. I was a complete stranger to this country at that time, barely been in the country 2-3 years, and I decided to stay. So my thesis project, when it was done, most MDs had never heard of it. The couple that had, Mark Mewson, one of them, basically said, what you did is mycin for yeast. I was like, okay, what the heck is mycin? And so I got a crash course in the field of AI in medicine through Mark and other collaborators. Found Ted Shortlift, found AMIA, so that is sort of my other community that I found. And I straddled ISMB and AMIA for several years, and now I'm more AMIA than ISMB. All right, so that's this little thing here. So that was 2000, 2005. 2005 to 10, I spent time building plumbing at the National Center for Biomedical Ontology. And plumbing is best not shown, as they say, so that's why it's not on the slide. But if it doesn't work, life gets complicated. And the efforts that I led there were all about how do you annotate large amounts of data semi-automatically so that then you can do something with it. That was sort of the one-line version. In 2010, so 5 to 10, I was postdoc plus research scientist, dabbled in a startup, had a child, bought a house. Life got too complicated, and so just had to pick a line of work, and so said, all right, let's be a professor, or let's at least try. And joined the faculty in 2011, technically. September was when I got my offer letter, September 2010. And I knew how to work with ontologies, I knew how to program, and I'd heard of this thing called EHRs, and that everybody was talking about them. And so I said, if I have a medical degree and I know these things, what would I do? So I started studying EHRs. So a fan of Russ's work, he was doing drug safety, so I was like, fine, let me give a shot at that. Got 2 R01s, one from NIGMS, one from NLM. Again, part of the whole tribe thing, you got to find your people, the program officers, the reviewers. 2015, I got tenure and a paper that got an editorial saying this is the future of pharmacovigilance. And I was like, damn, now I have to do this for a very long time. And then I'm a fan of Larry, so one of his other things was that after tenure, if you don't do anything that would have otherwise gotten you fired, you're not using tenure. Like, okay, what am I going to do now? So I said, all right, I'm going to quit pharmacovigilance. Yeah, quit while you're ahead, right? And so I launched two separate efforts, both sort of tied to the two grants that I had. The first one was about prediction. And I make a hard distinction between prediction and classification. General speaking, we might say things like, here's an image and I predict there's a dog in there. That's not a real prediction, that's a classification. Diagnosing a person with pneumonia or sepsis is classification. Prediction is you tell me something that has not happened yet. In this case, we're predicting cost of care 12 months from now, and believe it or not, and this is not planned, using data from Denmark. Because they have good data. They have awesome data. And then when that paper came out, a couple of investors in the US got interested and said, will this work in US data? I was like, I don't know, get me some data. They got me the data. They said, well, get me some money. They got me the money. I was like, damn, I have to do this one now. So we validated it in the US. It worked. We spun out a company. That company is still alive and well after 9 years. And then on that basis, I wrote an R35, a Mira Award, which we had a session on yesterday. It got clobbered, like completely clobbered. So yeah, I'm tenured, and one of Russ's saying is that, before tenure you get a bad review, you think I'm stupid. After tenure you get a bad review, it's like those reviewers are stupid, right? And so like, what am I going to do now? So I took that thing and then showed it to our development office, who took it to a donor, and then the donor essentially gave me a Mira Award for life. So that's thread. We'll come back to that in a second. And then the other big one, this one, like I started after tenure, like the thing that Larry was suggesting. How many of you have done an observational study using claims or EHR data? A couple, like 5–10%, right? How long did it take you? Years. Even if you're super efficient, like you're part of the Odyssey community, you know the OMOP schema and everything, it's still going to take you 6 to 9 months. I put the goal of getting that done in under a day. The statisticians thought I was nuts. The informatics people thought I was nuts. The computer scientists thought I was nuts. The only person to believe in me at that point was Reed Jobs, Steve Jobs' son. And they wrote the seed grant, a seed check. NLM immediately saw the value of that and gave me my second R01. And we took on this 5-year journey of looking at everything that is done in doing an observational study, and with an engineering lens, making it fast. By the end of the time, by end of 2018 or so, we launched a bedside service to do this on demand, and on campus, we got it down to a 24-hour turnaround. We then spun out a company that has now gotten it to a 2-hour turnaround. 2 hours from question to answer. If you trace back history, the first time a doctor imagined doing this was 1972. There's a paper by Alvan Feinstein titled Estimating Prognosis with a Conversational Mode Computer Program. And it does pretty much everything we did in 2018. Has its own ontology. They don't call it an ontology. They have a notion of similarity. It's interactive, yada, yada. So this got done in 2020, right? We submitted the publication end of Feb 2020. And then March 16, the world shut down. The paper took about a year and a half to get reviewed, and then ultimately came out in the New England Journal Catalyst and all that. But COVID for 2 years, had a little health scare during that time, during COVID. And then I was full professor by then. Again, it was like, what am I going to do now? So I wrote up 2 pages that led to the creation of a data science team at Stanford Healthcare. And some of my colleagues are here, Jonathan Chen, Roxana, Emily, Tina Hernandez. I don't know whether she was here yesterday. And we basically try to take things, what we do, to the clinic, to the bedside. It's not easy. We'll tell you lots of stories about that too. I have about 12 more minutes, is that correct? So why does all of this matter? The bedside consultation, which is the lowermost middle column box, That matters because here's a paper I'm not involved with. This is the state of the art of decision making at the bedside. About 80% of decisions made in this week by these physicians were estimated to have no basis in any prior published data, and less than 3% had a study specific to the question at hand. If you ask a cardiologist, amongst the most well-studied field with grade A evidence, as they like to call it, only about 19 to 20% of their evidence is backed by an RCT. And you ask a physician how often patient walks in and you have an RCT that applies, like less than 20%. Even if it's 20%, 20% times 20% is 4%. Rest of the time we're guessing. Educated guesses based on some precedent, based on some prior patterns that we've seen. And we store that in the EHR, and we do nothing with that. So that was the problem we took on, and now the company can do this. Of course, they have to use LLMs, but they can do it in hours. It's amazing. Now, people ask me, what do you do with this? I say, I have no idea what you do with this. Where you have a question, and if you want answers from the data, press a button, and you get the answer. What do you do with an internet search? Like, I don't know. Some people search for hotels and conferences and publications. Other people search for other things. On our health system, this has been used by every service line. The largest user is, believe it or not, pharmacy. People in ENT have used it, gotten JAMA papers just by querying an automated system. All right, so that's that. And then all of the stuff here, the 2013 to 2018, that essentially funneled or sort of supported the work, and I'm looking for my highlighter, that became here. So all of this is based on the work in that middle box. It's about 40-ish papers worth of work. I'm not going to go through all of them. The gist of it is, if you're making predictions, what matters is what can you achieve given work capacity. So we spend way too much time on this upfront, the model. Did we build the model right? And is it well calibrated, this and that? And is it a neural net or a regression or what have you? What we don't do is spend time in that green box. Now, I'll give you a stark example. There's this model by a company called Vizia, I have no affiliation with them, that can read an MRI or a CT scan and say, is this bleed hemorrhagic, or is this stroke hemorrhagic or ischemic? And if it's hemorrhagic, you can put the person on a helicopter, and this is for Central California, fly them to UC Davis, they drill a hole, get the blood out, save the person's life. Okay, great model. If you don't have a helicopter, you're still toast. So capacity is king. And so what we've started focusing on is creating weird-looking plots like this, where on the x-axis is rank-ordered list of cases. Whatever prediction classification that you might have made, just rank it by 1 minus the probability. And then by doing action on the first case, you get some benefit, some utility, hours saved, life saved, money saved, doesn't matter. And then as you go down, it adds up. So it's cumulative. It's going up. At some point, it hits a maximum and then keeps coming down, diminishing returns, as they say. What matters the most is what is feasible given your capacity. How far down the list can you go? And that is the reason I prohibit my students from ever building a readmission model or a sepsis model. It's very hard to march down the list. I'm not saying those are not important problems, super important problems. They're just not amenable yet to the kind of machine learning we are throwing at it, because we're not paying attention to this other stuff. Okay, so all of this was going on based on work done on this previous slide. I'd been part of founding or starting another community called Odyssey, Observational Health Data Science and Informatics. And this work here is the basis of another community called Shah, Coalition for Health AI. Life was great. I thought I had all figured out. And then along came large language models. Like, what the heck? And so the immediate reaction from a lot of people was to start using them. But we had been looking at these for a while. The first paper from my team on using this technology, language modeling, I put it in quotes because I'm going to unpack that. It got published in 2021. Jonathan Chen has been looking at it since GPT-2 came out or something. And so he said, all right, let's take a step back. What is worth doing here? So this didn't happen in exactly this order, but it makes more sense this way. So here's a review that one of the attendees, Suhana Bedi, led. We looked at about 519 papers and asked 5 questions. What is that data source you're using? What is the healthcare task you're attempting to accomplish? What is the language task you're attempting to accomplish? How are you evaluating it, or what metric, and what medical specialty? 5 questions, okay? 95% of the papers that were in PubMed at that time were making their claims and conclusions without using any EHR data. They're using language models, but no EHR data. None, zip. The task that we loved doing at that time was enhancing medical knowledge, which is a euphemism for taking and passing the USMLE exam. The language task is question answering, no surprise. We're fixated on accuracy, the first column. Not much attention to factuality, which is the third column, or robustness, or fairness, or deployment, or calibration, or anything of that nature. Like, oh, that sucks. So we started verifying benefits of off-the-shelf LLMs, and Jonathan has some amazing work in that space looking at clinical decision-making. I already told you about the bedside question answering, so we just took a bunch of questions, about 66 of them, and posed them to GPT-3, that's the first column. Second column is GPT-4, and asked 12 physicians, given the reference answer and that what one of these language models are telling you, are they agreeing, disagreeing, or you can't assess? So GPT 3.5 to 4, life is good, agreement is up, disagreement is down, unable to assess is down. But the headline is about half the time the 12 people couldn't agree on what was the case. That didn't change. That's like having a super confident person at the bedside that can say something and you don't know whether it's right or wrong. Typically a second-year med student. All right, so there are definitely a few med people in here. And the other one we did was a little bit more principled, where we took this stuff in the blue box, things a physician would want the language model to do for them. Summarized from the EHR the stroke the patient had and their associated neurological deficits. Fed the EHR itself, send both things to a language model. We asked the physician to type out the expected answer and have the language model do the same. Even in the best case setting, 35% error rate, 3.5. Now probably down to the 20% range. So this data set is just released. It's called MedAlign, and I'll have a slide on that in just a sec. All right, so let's go back to that timeline thing and that language quotes, and I got 3-4 minutes left. So the patient timeline has a language. The EHR language, I'm not talking about notes, the English, Spanish, German, Danish, or what have you. I'm talking about the tokens, the codes, the amino acids of the EHR. ICD-10 codes, CPT codes, OTIX norm, LOINC codes, and so on. It's a symbol space of about 15,000 tokens, unique tokens. We have millions of chains of them. They have a few peculiarities. They have large introns in terms of time. And we're also not usually interested in predicting the next token. We're kind of interested in predicting time to a certain token. Now, I don't know of any language model, a traditional language model that has been trained on reading prose and saying how many words will pass till I see Fairmont. Nobody trains that way. So the training function is not even aligned with what we're interested in. But we just keep hammering on those things. We just beat them. All right, so if we subscribe to this, then we have 2 ways to build language models. And I put language in quotes because I'm not talking about natural language or only natural language. The top part is natural language, documents. And you can create a language model that can do generative tasks like chat and summarization. But typically, we again train those things on the Reddit and the Common Crawl and internet and not on EHRs. There's a few. There's Gatortron from NVIDIA and University of Florida. There's one from UCSF. But so we're not going to talk too much about those. The lower ones, where we're looking at entire timelines and the tokens that appear, if we train them right, we can forecast what is going to happen. So I'll just show you a picture. What are the benefits of these timeline-trained models? X-axis is the examples you need to learn a classifier or a predictor. Y-axis is AUROC, one of the performance metrics. The dark blue line is the timeline-trained language model. I'm cheating a little bit. There's two of them, Climber and Motor, but I'll just show you one. And then the other colors are gradient-boosted, regressions, random forest. And the bottom line is that with about 64 examples right here, you can match the performance of these other techniques that use all the data. Sample efficiency. So you can now take these things and build classifiers for rare diseases. If you want to talk more about that, go chat with Suhana. I'm not going to tell you anything more. You get higher accuracy, it trains 8 times faster, 95% less training data. So to wrap this up, in this new age, we really need to focus on this purple thing of verifying benefits. We spend way too much mental energy on building models, and if we choose to do that, let's look at the unique needs of medicine and healthcare. Like, how many words pass until I see heart attack, rather than just taking stuff off the shelf. Take stuff off the shelf, but fine-tune it. I'm not going to talk about the deployment challenges. Happy to talk about that over the lunches and the breaks. Don't believe everything I say. This conference does give out a data parasite award, and if you are a data parasite, I got 3 data sets for you to check all of these things, the claims that I've been making. The URL up there will get you to those data sets. You will have to sign a DUA, even though they're de-identified. And then if you're interested in building models with this new way of thinking about them, there's a bunch of experiments on that too. The first 2 are those timeline-trained models already published and released. We're the first team to release foundation models trained on EHR data. And then we're looking at alternative architectures. Why should we just stick with transformers? There's Hyena, there's Mamba, there's different context lens. Like if we're building models, we should be thinking about, are we building them right for the problem at hand, rather than just forking over money to big tech on API calls. So I'll wrap up with the key challenges and opportunities. 2 and 3 is what we talked about, interplay of models, work capacity and action, and devising evaluations that verify presumed benefits. But those don't mean much until we can have deployment readiness, or we can pair technical innovation with high patient benefit. So I'll stop here.
Thank you very much, and actually those 2 TERI talks couldn't have kind of meshed together more beautifully. So thanks to Soren and Nigam, who